There he is. Hey, Patrick.
Hey, Devin, your background is insane.
You like that?
It's absolutely wild. What
Yes,
is it? What's
yes.
that from? Is that from something?
It's a COVID ship. So I got my Puro up here. Uh, got some spike proteins on the outside. Yeah, you know.
My goodness, that's too funny.
Yeah.
That's so fun, dude. Are we live right now too? Is that how this works? It just perpetually live? Oh, we're streaming. Okay, guess it. Yeah, we are live.
Yeah, I think we're streaming. I just joined. I think I'm the first one.
Okay.
So quick run through. I listened to some sessions yesterday. I can kind of show you how it works.
Yeah, sure.
So you're looking at that that main page, right? The baseline protocol, Quico chat. If you look in the middle of the page, you should see something that says instructions, and there's like a Google Doc in the middle. How about this? I'm going to share
Yeah.
my slide. You can see what I'm talking about. Yeah, there you go. Oh, man. 1 second. Yeah, is that you typing?
Yeah, it's me typing.
Okay. Now the slides in that same page, you see there's a tab at the top that says slides. If you click on that, it's actually empty. But maybe there's some way you can just do a copy and paste of all your chain link slides. I'm not too sure. Worst case, you can just screen share.
Let's see if does this work? Oh, it worked. Nice. Oh, it almost worked. It mostly worked. Oh no, it did work.
Hey, folks.
Hey, John.
How's it going, John?
Yeah, pretty good. I'm running around being AV guy here. So you are on live stream. Okay, cool. And yeah, everything should be working. I think I see. Yep, everything's up. So I'll be back, and please have at.
All right, cool. Well, let's do it then. Let me.
Yeah, really. The live stream people will be able to go back and see this. People that are waking up later.
Yeah. All right. Perfect. So I'm going to go ahead and go to presenter view for this, and start sharing my screen, and we'll jump into it because we got a lot to cover today.
I'm going to tweet this right now.
All right, cool. All right, cool. Well, it's 7. Devin, you ready to get going?
Yeah, all set. Cheers.
All right, cool. I'm jumping right in then. Welcome, everybody. Welcome to the Chainlink Oracle's baseline presentation here. I'm here with Devin from Google, and we're really, really excited to be doing this demo, doing this presentation. There's a lot of stuff for us to go over, so I'm not going to waste any time. We're just going to jump right into it. So, yeah, and Devin's just going to be jumping in. Like I said, he's from Google. He's the Google expert here, and just kind of talking about why everything we're talking about is important, how to build with it, and yeah, let's go in. So, in this presentation, we're going to be talking about the smart contract connectivity problem, the standard for decentralized oracles, and then we're going to do an end-to-end, all-in-one, craziest, most jam-packed demo ever. And I'm really hoping we can get through everything because we're going to be trying to do a lot of awesome stuff. If we have to skip over some things, I apologize, but yeah, we got to see how much we can fit into this hour we have. So in this demo, we're going to be doing everything from scratch. And we're going to be doing a lot of really, really powerful things. And everything is using the Google Cloud Platform Suite. So we're going to be setting up a Chainlink node from scratch. So there's only a couple of tweaks I made before this demo, but pretty much everything's from scratch. And I'll note the parts that I already touched on. We're going to be setting up a Chainlink external adapter for Google's BigQuery using Google Cloud Functions. And I'll explain what that means in a little bit. And then an end-to-end demonstration showing all these pieces working together. So the smart contract connectivity problem is really important, and it's the first thing we need to understand in order to really understand Chainlink. And in order to really understand Chainlink, we must first understand that smart contracts are not able to connect to external data or any off-chain resource on their own. And this is a huge limiting factor for smart contract and blockchain adoption. Meaning the only thing we can kind of do is these token transfers and make these tokens and just send Bitcoin, send Ethereum. That's really all we can do because they can't get data. So the question for us engineers is, okay, well, why doesn't blockchain just make API calls? That's what every other technology does. And this is actually a really important question. And it's because blockchains are actually deterministic, meaning that if you replayed the entire blockchain from the Genesis block at block 0 to exactly where we are now, you should end up in the exact same state. Now, if you add API calls into this for this consensus mechanism, then nodes are not going to be able to sync up and agree with what the state is, right? Because if one node makes a call to a service at time X, and then another makes an API call to that same service at X plus 1, based off of who's maintaining the service, it could be updated, it could be hacked, it could be different, and it's going to be impossible for the nodes to come to a consensus on what the state of the blockchain actually is. So this is really, really important. And it's why these smart contracts can't natively, or these smart contracts and blockchain platforms can't natively make API calls and get data here. So in order to interact with the world, because we still want data, in order to make these smart contracts do more interesting things, we need to call what's called an oracle. And an oracle is any device that interacts with off-chain world to provide data to smart contracts. And it can also be the reverse. It can be any device that sends data from the blockchain or gets data onto the blockchain. So it's either way. It's this connecting middleware that connects the blockchain deterministic world to the real world. And this is where Chainlink comes in. So there are thousands of APIs that are already providing data that people need for their applications. And Chainlink makes it really easy to enable connectivity between those APIs and smart contract, even if they require authentication, even if there's some additional processing power. It's really this middleware that allows smart contracts to unlock their full potential and do whatever they want. So in addition with this, like I said, not only getting data is important, but paying out users. A lot of users don't understand cryptocurrency, and they need to get paid out in the currency that they want. So again, Chainlink has this functionality called external adapters, where they can actually be customized to do whatever you want them to do. So you build a simple server, a simple serverless function, which is actually what we're going to be going into today. And you can get and send any data from the blockchain, anything that you want to do. And the great part about this is that external adapters can be written in any language that you want. So you don't even need to know anything about Solidity, anything about blockchain, and you can become an external adapter developer. Now here's something that's really important. Probably one of the most important pieces that we're going to go over today. A centralized oracle in your smart contract becomes a single point of failure for the entire smart contract. And this is why we create decentralized oracles. So if you have a centralized node, a centralized data source, and you have a decentralized smart contract, you've basically ruined and removed all of the effort you've gone through to build this decentralized platform. I mean, building on blockchain is difficult. If you're going to build on blockchain and have a centralized service, then you might as well just build with Python, build with Node.js, build with some centralized service where you have a server. If you're going to go through all the trouble of building on a decentralized platform like blockchain and then make it centralized, you're kind of defeating the purpose of doing it. Now, saying a Chainlink node by itself is decentralized, kind of like calling a tree a forest. A single entity, a single Chainlink node does not make your smart contract decentralized. To make applications that truly never need to rely on one entity, be a company, landlord, government, you need a network of Chainlink nodes. So you never want this centralized entity here. And Chainlink allows you to bring data from many different independent node operators and independent data sources. And that's where the power of this really is. It has that same, it's going with the same philosophy that makes blockchain work today. The reason blockchain works today is because you have a decentralized network of nodes that decide consensus, that they decide how code runs. It's the same thing for getting data, getting and sending data. And I'm stressing this point so much, not only because it's really, really important, but we've actually seen attacks that have lost projects literally millions of dollars already. So this is, just hearsay. This is things that have actually happened. And the entire problem was that they were using a centralized oracle. That centralized oracle was hijacked. They were not malicious oracles. They were just hijacked, and somebody attacked them. And since smart contracts automatically execute whenever the data is met, they kicked out. So Chainlink is designed to be this modular infrastructure that can build a decentralized Oracle network used to connect smart contracts to any API and any data source. And to get you started and to make it a little bit easier, the Chainlink project has actually gone ahead and found many of the best blockchain node operators on the planet, combine their prowess to build what's called price feeds. Now, these are the standard for decentralized oracles in DeFi right now and are powering many of the top DeFi projects on the planet. So here's a quick look at what they do. It's a visualization of what they are. In the middle, you can see the price of FUSD, and obviously this picture was taken from a couple months ago, back when it was $200. But you have all these independent node operators. That's what's surrounding this. All these are independent node operators providing data on chain, and it gets aggregated on chain. So we have this definitive truth that projects can now use to reference and say, oh, the price of ETH is $200. The price of ETH is $450 or whatever it actually is right now. So we can create this definitive truth on chain using all these independent node operators. And again, because it's decentralized, if any of these go down or kick out or report poorly, the decentrality of the network allows it to continue on. And then those who act maliciously get bad reputation and get kicked off. So I know I'm going to be going pretty quick here. But if there's any questions, feel free to jump in.
Oh, this is great, Patrick. I just made sure everybody knew. I mean, it's early for the U.S. folks. We had hundreds of people on yesterday, and people are watching the live streams pretty heavily. So I think the key will be the people will be able to scrub back to this,
great, and
then really get to work on coming up with the issues and epics that they're gonna build for the hackathon. And that's really how I'm hoping this will go. But we already do have some people. Anais Frank, who's one of the great leaders in the community, is already on. Hi, Anais.
Awesome.
And we got Devin here, and I guess us. So we'll be able to use this this material as we go into the day.
Perfect. Cool. Well, I'm going to keep going because we want to get to these demos here.
I will say the trick is for this session in particular, throwing out some fish hooks, as it were, for people to say, okay, not just here's the demo, but if you can maybe hop into the code and give people clues as to how they can set up and discuss not only what they might build in terms of demos for the hackathon, but it's actually good that Anais is here because we can talk about how the standard for the baseline protocol standard should evolve to accommodate Google type data and also Chainlink.
Yeah, so let me actually jump to the end real quick, and then I'll backtrack. So that's a really good point you make. And then actually we can even go on DeFi Llama. Yeah, we'll just do DeFi Pulse. So for those of you who don't know, DeFi Pulse it's a website that kind of tracks all the different projects in DeFi and then how much money is locked under them. So we're really excited because all of DeFi is almost 14 billion right now. But we can take a look at some of the projects: Uniswap, Maker, Wrap Bitcoin, Compound, and a ton of these top projects that are securing billions of dollars are powered by these Chainlink price feeds. Aave, Synthetics, Finance, I think Nexus, I don't want to say anybody who's not, I think Nexus Mutual, Set Protocol, Loopring, you know, a lot of these BZX, a lot of these projects, they're using Chainlink price sheets because they know how powerful it is, and they know how easy it is. And, you know, the amount of money that these protocols have locked in is really a testament to Chainlink being the standard for your decentralized oracles. It's a way to get this definitive truth on what the price of, you know, whatever is. And the other fantastic thing is that if you're looking for other data, more interesting data, like data from Google's BigQuery, which we're going to go into in just a minute, Chainlink allows a framework to get that data also in a reliable, secure, decentralized manner, which is really exciting here. So let me go back. Oh, that's right. This is it's DeFi Pulse. So let me go back here, and we're going to go over the demo overview with these oracles in the cloud, how to set them up, what they're really doing. So oracles in the cloud, the infrastructure is we're going to be running a Chainlink node on a virtual server on a Google Cloud VM. We also will be connecting to an Ethereum node. We won't be in ETH2. You can run these virtually, but for this demo, we're going to be using a third-party provider. The reason why running them in the cloud is so good is because, you know, they do require this constant uptime. They do require this constant availability. They need to be able to connect with a lot of other servers. They need to be highly available in a production instance. There's a lot of pieces that make running these in the cloud highly advantageous, and Google has all the services to run literally everything in the cloud, which is fantastic. So yeah, real world data lives everywhere: servers, public databases, you know, cloud computing. Yeah, we're going to be looking at the Ethereum Aave data set. I'll show you that in a minute here. We're going to be looking through some Aave data. Here's a quick visualization of the crypto public data. I don't know if Devin, you wanted to jump in and talk a little bit about this.
Yeah, sure. Thanks, Patrick. Hey, everybody. Devin mentioned I'm at Google Cloud. I'm based here in Singapore, but I work with a number of customers that are in the blockchain space, and it's been a real pleasure to join this call alongside Consensus and Chainlink here to really talk about our public data sets program. And yeah, if you want to learn more, there's 2 links at the top here. You can check those out on your own. But what we've really built here over the past 2 years is a tool which runs on Kubernetes, which is a cluster computing fabric that we've open sourced. It actually runs Google's own production infrastructure, and we use this to run multiple Ethereum clients and containers. And there's a gentleman, Alan Day, who is our developer relations lead, who runs this program. I helped a couple of years back as we migrated this into Kubernetes. And really what this does, and this gets away from the demo here, but at a super high level, Kubernetes helps run this Ethereum infrastructure and run it at scale in an adaptable framework where uptime is critical, to the previous points that Patrick made. And what we're doing here is we're running these Ethereum nodes. We've been running them for 2 years. And for every block that comes out on the Ethereum blockchain, we capture that block. We take all the data out of that block, full archive, and we store that data nice and neat inside BigQuery. And we make this available as a public service as part of our BigQuery public dataset program. And so what Patrick will dig into is just one of the many data sets that's available here within BigQuery. One last call out before I hand back to Patrick, but we do have a lab that's the second link there. If you do want to kind of stretch your mind a bit and try and understand how to look at Ethereum in general in terms of understanding block data and performing tasks such as data analytics on this Ethereum block data. There's some great labs that we have available on that second link. You can try it out, and it should give you a really interesting, unique idea of how to do analytics on blockchain. We have a fun one in there around the infamous the 10 Bitcoin pizza from a few years back. Always a fun one. But yeah, with that, this demo really just focuses on the crypto data set.
Cool. Yeah, thank you so much for the background there. And yeah, just a little bit more on the demo here. Just another visualization of the Ethereum node and the Chainlink Oracle on, in the cloud, in the Google Cloud. You see like the Ethereum node can be its own virtual machine. The Chainlink node, which is what we're going to be interacting with, is going to be is a virtual machine here. And it's going to be the one that's actually interacting with reading and writing from, the data of things. We're going to be connecting our Chainlink Oracle to a BigQuery, what's called an external adapter, like I was saying. That external adapter runs in Google Cloud Function and connects to these public data sets, connects to Google's BigQuery, and allows you to get that data on chain, which is fantastic. So with that, we're going to jump right into it. And there's that picture again. So let me actually change my share screen settings. Where's the Zoom button? New share. So I have a really big screen. So we're just gonna zoom in on some of these guys. And then let me know if you can see these okay. So everything for this demo is in this repo, all the instructions for it. These are the two repos we're going to mainly be using. We're going to also be using some documentation. Yeah, all the instructions will be in here. Feel free to refer back to this video to kind of do all this stuff. So what we're going to be doing is these three main things. Setting up a node on the GCP. Can you guys see this okay, by the way? You can see it? Okay, cool. Setting up a node, a Chainlink node on the GCP, setting up a BigQuery external adapter. And again, we'll show you exactly what that means. We'll connect to the BigQuery external adapter to Cloud Functions and run an internet demo. And we have 40 minutes. So this is probably the most ambitious demo ever. Hopefully the demo gods will look, kindly on us, and hopefully we'll be able to get through everything. So first thing that we need to do is we need to create our free GCP account, right? So I actually already have it set up. You do have to put in some information, like your name, who you are, but it's free, and it doesn't turn billing on until you actually turn it on. So you see, you get $300 credit and 90 days. I've been messing around with it for a little bit, so that's why it's a little bit lower. But cool. So I already have my free account, and you'll need to enable a couple of APIs basically to get started, like the BigQuery API. It just kind of looks like this. You can look up like networking API, networking service. This is another one that you have to enable. It's a good thing that I looked it up. Yeah, you literally just hit like enable. And usually if you're trying to use a service for a purpose that, the API isn't enabled, it'll usually flag you. It'll say, hey, you need this service. So let's go back. And this is my demo link notification account. So cool. We've enabled that. We've enabled the networking service API. And again, it'll like flag you if you don't have them. Now we want to set up a VM instance. So this is going to be our virtual machine. This is where most of the Chainlink code is actually going to live. Hopefully you guys can see everything here okay. And this code on the left here. We'll be going over this in a little bit. Let me zoom in a little bit more. But we're going to create a VM instance. We're going to call it Chainlink node. And then everything we're doing here, like I said, is real time. We're going to call it Chainlink node Coven demo. Region doesn't really matter for when you go production. Region matters a little bit because you want to have your high availability in different regions in case one region gets blown out. We're going to do, I don't think we want E2. N2. I forget what the difference between E2 and N2 is.
Yeah, different chip types, depending on if you're maybe more CPU hungry or memory hungry. Maybe for this case, N2 is pretty decent.
Okay. Yeah, I think N2 is what I used on my last demo. But yeah, so two cores, 8 gigs of memory is probably well, not probably, it's definitely overkill for this demo, but we'll just stick with it just so we have a nice, powerful, and then I'll just, I'll tear it down afterwards. Cool. So we're going to change this. I'm actually prefer Ubuntu for my Linux flavor. Let's go to 18, SSD 10 gigs. Great. So you can kind of customize your size. You want to add existing disks, snapshots, custom images, whatever you want. You can kind of add it all here. We're just going to select kind of a real basic Ubuntu version. We're going to allow these. We're going to kind of skimp on some of the security pieces just so we can kind of get through everything here. But yeah, usually you want to enable deletion protection so that it doesn't kick out. Add a startup script, whatever you want to do. But we're just going to kind of go bare bones here and create, which is great. So this will actually start creating. And while this creates, we're actually going to set up our Postgres database because this actually will take a minute. So you can find, everything that you want to find in this little button over here. If you want to pin something, you can pin it. Like, for example, I usually pin Compute Engine because that's where the VMs are. And we're going to be playing with that a lot. We're also going to pin SQL because this is where we're creating our Postgres database. So the Chainlink code works best with the Postgres database. So we're going to create an instance. We're going to choose Postgres. And yeah, same thing. We'll add in our name. We'll call it Chainlink Postgres instance. Default user password. I'm just going to call it password for now, and then just tear down the instance afterwards, like I said.
That's where they get you, man. It's on the password.
Yeah, right. I just have to remember to tear down the instance afterwards. Luckily, billing is not enabled, so if I get attacked, it's fine.
How did you know my Google password?
Too good. Yeah, anyways, so we're going to choose Postgres version 12, 11, 12. I don't know about 13, but 11 or 12 work with the Chainlink code. 13 probably works too, but I know for a fact 11 and 12 work. We are going to make it a private IP actually, so you can't attack me with this demo anyways. And associated networking default is fine. Actually, we probably can just make it public. Now let's keep it private for the demo. But yeah, again, this is where, if you want a production one, you're going to come in here, you're going to make it highly available. You can change your backup time. It's super customizable to fit whatever need that you're looking for. So I think we are good here. Let's create, and this one will actually take a little bit. So hopefully our Chainlink node VM is up, and it looks like it is. Yay. So that's very good. Enabled networking API. Cool. I just did that. I didn't have to add these. So I need to change this README to say you might need to add context manager. Add a user to the database. So once, did I hit create? Oh, it's creating still. So while this Postgres database is loading, we can go in here and we can SSH into our machine. And for those of you familiar with Linux, it's literally, it's exactly what it is. It's a Linux virtual machine here. So our first SSH takes a little bit of time because it's kind of figuring everything out. And great. Now we have our brand new instance here. We have nothing in here, which is great. So this is going to keep taking a little bit of time so we can move on to some of the next steps here. So the next step, we actually have to install the Google Cloud SDK on our machine. And the reason for this is because we actually have to SSH tunnel into our Chainlink node to stay protected and so that we can, what am I trying to say? So we can stay safe and we can view the UI. So I'm actually going to log out of this one, come into here, clear. I'm going to zoom in on this so we can see this a little bit better. Again, our Postgres database is still setting up, and I'm just trying to be fast because I want to get to everything here. And now we can, so I've already installed the Google Cloud SDK. The docs here are really straightforward. You just go to the docs here and install that on your local machine. Once it's installed, we can actually SSH tunnel into our machine. So I'm just going to log in, gcloud auth login, and it should kick me out over to here. This is the account that I'm using for this demo, and allow. Great. So now we're logged in. Now we just need to set the correct project ID. It's going to be this one. So we do gcloud config set project. I think that's what we do, right? Yep, cool. So now I'm logged in. I'm logged into the Google Cloud SDK on my local machine, and I have the correct project set. So now I can work with this one. And this is probably still updating. Yep, that's fine. So once you have this, once you're logged in, you can SSH tunnel into the machine. So with this command here, gcloud compute -- project, that project SSID, or that project ID, excuse me, oops. SSH zone, let's check the zone on this guy, US Central A.
Yeah, we've got people are pouring in, seeing the live stream, and also we've got Juan Blancos here, Chris Grublak, and Anais, Patrick.
So
that's you. So folks, feel free to, this is a safe space to ask questions, right?
Yep, for sure. So I'm not monitoring the chat, so if somebody asks a question, just ping me, and I'm happy to answer.
We'll keep an eye on it. And also, I just went into the summit floor and let folks know people are starting to wake up.
Awesome, great. Yeah, because I know we're going to be touching a lot of stuff here. So yep. So this is the same thing now. So we're now in the same machine that we just SSH'd into. This is exactly, like I said, this is exactly the same machine, but we're just logged in from our local instead of from the browser. So we can keep going while this, while the database kind of still boots up here. Now we can actually go through the docs for running a Chainlink node. I'm going to zoom in again here, and everything you need to know is in here. And we're going to kind of breeze through it a little bit. I've done this 100 times. So first thing we need to do is we're going to install Docker, and this is actually going to kick us out of the terminal, and then we're just going to log back in. So installing Docker here. And again, this is on our virtual machine right now. This is in the cloud. We're running this in the cloud. We're not running this on our local machine, even though it looks like it's on our local machine. And this just, it just does a whole bunch of, sudo apt get install, give us Docker. That's basically what this is saying, give us Docker. And then it kicks us out. Great. So now we're just going to log back in. Now that Docker is up, and we can do stuff like Docker PS, and great. So it says we have no containers running, but Docker is installed. Perfect. Now we're going to go through the more Ethereum blockchain-y parts. So we're going to make this directory for Rinkeby. I'm going to go kind of quickly through this because again, we have a lot to get through. We're gonna set this up here. These are all the parameters in our Chainlink node that we need for it to understand how to connect, how to do pretty much anything. The only additional piece that we're going to need here is we're going to need to connect to an Ethereum client. So in order for the Chainlink node to read the Ethereum chain, it needs something to read from. So we need to give it an Ethereum client. You can run an Ethereum client on the same machine. I would 100% not recommend that on Google Cloud because you're going to need, 100 gigabytes of space.
I think that's perfectly fine. Devin, you have no problem with people running 100 gigabytes on
always
GCP,
run
right?
a light node.
Yeah, they're very happy to let you do that.
I was going to say, can you run a? I don't know if you can run a light node for the Chainlink node, but can you? Are you allowed to run a light node in the GCP?
Yeah, so GCP, when it comes to general terms and conditions, right, it's really just centered around avoiding tasks like mining and the like. But the way we run it for our public data set program, we run the Ethereum nodes as a full node in full archive, and runs just fine with mining disabled.
Oh, just mining is disabled. Oh, cool. All right, so then never mind. You can absolutely do that.
Yes.
I should quickly hasten to add, I was kidding. But
Quick question, Devin. Are you planning to expose your nodes for anybody to query them using like Google Functions or mainly like that Patrick is doing with Chainlink?
Yeah, it's a good question, Juan. So if I understand your question, it's would we add more functionality? And yeah, really just what we have here is really just more for public data. We're running these nodes to capture the raw Ethereum block data to make available for data scientists, through our public data program. Yeah.
Yeah, so my question was, are you planning to expose the RPC connections from your nodes, so having that as an offering? So like Patrick was demonstrated, you need to configure your own node, like maybe connected to Infura. So are you planning to use it as a service for your internal consumption?
Oh yeah, no plans for that. This is we really just run these nodes for driving the public data set program. But a lot of customers do choose, I think, to use Google Cloud, just like other clouds, maybe to run nodes, maybe for their own purposes for development and the like.
Right, that makes sense.
Okay, thank you.
All right, keep going, Patrick.
Speaking of nodes, actually, that's perfect timing because, like I said, we do need an Ethereum node for our Chainlink node to read off of. And again, because Chainlink is blockchain agnostic, this works for any EVM compatible chain. For non-EVM compatible chains, there's a little bit different of a process here, but for EVM compatible chains, you just grab an RPC URL and you prop it into your .env file. So this is Fuse. This is the service we're going to be using to get a Chainlink a Chainlink RPC URL. So you just sign up for a membership. You hit, give me a free RPC URL, and once it gets me one, then we can add it in here. And if it takes super long, maybe we could try another service, but usually it's pretty quick. Let's check on the database while it's database is up. Okay, cool. So I know we're flipping back a lot back and forth, but feel free to, we have another video on this. Just go ahead and look up Chainlink Node GCP, find that video. You follow that verbatim. And also the docs say literally everything to do here. So I know we're flipping back and forth a little bit. So while this gives us an RPC URL, let's do this other bit where we needed to add a database and a user to our SQL instance or our Postgres instance. So this is our Postgres instance. It's got everything we want to know in here. We're just going to go ahead and add a new database. We're going to call it Chainlink Node Demo. And great, now we have a new Postgres database called Chainlink Node Demo, and we're just going to add a user, and we're going to call it. I think we're going to do a Postgres user. We're just going to call it, Chainlink Node Demo. And the password is going to be John's password again. Password. So, sorry, John, for exposing you here. Anyways, so it looks like Fuse is taking a little bit to. Oh, maybe because I need to sign in, huh? Forget what I have like a list of like fake passwords that I use, and I forget which one I did for this demo. Is it this one? Okay, cool. It was that one. So new subscription, use free trial. Got it. It just needed to do connect. This is only does Ropsten actually. So just kidding. We're going to use Infura for this. I believe I have an Infura account. Actually, let me just stop share screening for a second. So you can grab an RPC URL from Infura. Fuse actually has only mainnet and Ropsten. I forgot, and we're doing a Rinkeby demo. So let me stop sharing my screen for just a second so I can grab the a Rinkeby RPC URL. Cool, got it.
2020 on chat here says, I'm missing my calculus class for this. Priorities.
Nice. Yes. Excellent. You were making the right call.
You need to code a differential in there, or maybe an integral.
Yeah, we'll do some quick differentials so that he can,
Chainlink has a calculus library, right?
yeah. Well, no, Chainlink can connect to any calculus library. So yeah, so we can sync up to Wolfram Alpha for you, and you can just, Wolfram Alpha how to calculus, and you'll get all the answers you need. But anyway, so I added a Rinkeby RPC URL in here. It's one of my test ones, but I use it for I don't want to have to get another one, basically. So that's why I didn't show it there. But great. So we have the database set up. We have the RPC URL set up. Where are we? We're in here. We're using Ethereum client as an external provider. We have 20 minutes left here. Whew. Now we need to set up the database here. So this is the string to connect to any database. We just have to change. We have to just change all the pieces in here. So let's just go to our this is our SQL instance again. We're going to change the user to Chainlink node demo. Again, our password was password. The server is a private IP, but we can just grab this right here, pop it in here, because our VM is in our private network here. So we can connect, but nobody else can connect. Port 5432. That's the default Postgres port, and the database is going to be this new one that we just made. And we're going to just drop it into our .env file. The .env file is going to be where most of your configuration is. So, so everything's in this Chainlink Rinkeby, because again, we're using the Rinkeby network. So we have our .env file. Great. We've set up the database URL. We've set it up for, if you're testing, yep, we might have to add this, but let's try it out first. Let's add this as well. And then let's start it up. So this is the startup script. And the only thing we have to do is add the version of Chainlink. Oh, whoops. Add the version of Chainlink here, and we're just going to do 0.9.4. And it's going to start pulling. So Docker is going to pull the 0.9.4. And I ran into an issue. Unable to create Ethereum scheme. I added a HTTP RPC URL. I needed to add a WebSocket. So let me grab that real quick. Infura. Yeah, so we need the WebSocket when we're actually connecting here, because it needs to constantly get updates, and it can't be doing pull requests like every second, and that would be really awful. So let me just grab the correct one. Apologies here. Go to Rinkeby WSS. Let me just add it to my .env file. Luckily, we have good logging. That's like probably one of my biggest pet peeves, is when a system doesn't have good logging and you can't figure out what's wrong. That one, the Chainlink code said right away, it said, hey, we don't understand HTTP. We need a WebSocket here. So let me share screen again. And let's try running that command again now that I've updated my .env. And great, we can see it's connecting to the database here. We're going to give it a new password. We're going to call it, again, John's password. Thank you for providing your password to the world.
And it's also my bank account password.
Oh, yep, bank account password. And somehow it's also your PIN. I don't know how you managed to do that, but it's also your PIN somehow. So we need to enter an email, test@test.io, and we're going to do password again here. So we are logged in. We are good to go. This is kind of just finishing setting up, connecting the database, and we should now, if we go here, we have the operator UI up, and we can log in with our test@test.io, and we are now logged into the Chainlink node. And this is where we can start adding interesting things. We can start doing jobs. We can look at bridges. There's a whole bunch of stuff we can do here. And everything that you're going to want to do is on this next fulfilling request page. So we're actually not going to have time to go through this fulfilling request, but I do have video where I go through this on another channel. And yeah, let's go over to the Google Cloud part. And I'll explain at the end how to connect this cloud function. We can do we could probably do a quick demo. We have 15 minutes left here. Let's go time. Go time.
Yeah, and maybe Patrick, one idea just for the new folks that join, maybe you can flip back to that architecture diagram and show folks kind of the pieces you just built.
Yeah, good point actually. Yeah, here we go. That up.
We got to get this. Well, so most of this demo code would be where, Patrick? Or do you think we can throw this into the repo?
Yeah, yeah, for
why
sure.
not?
So I have a link in that repo to the docs here. Some of the code. I mean, I did a lot of the setting up the VM and the Postgres through the UI. So that part's kind of hard to put into the README, but yeah, I can clean up the README to put the links to the Google Cloud Console and clean it up a little bit better because yeah, it's really it's really that simple.
Yeah, cool. Maybe we can get somebody to volunteer from the community as well to help out.
That'd be great. Yeah, if somebody watches this and understands everything and is able to spin it up, then that's fantastic. So this is at this point, honestly, right here, you should be pretty proud. You're like, wow, I have the UI up. You definitely want to do that fulfilling request parts because that's how you're going to really be able to interact with the Ethereum chain. We're going to just jump into the BigQuery external adapter because it's really, really powerful, and I want to be able to have time to show you guys this too. So
yeah, we want time to talk about where this could go in standards and specs as well.
Yep, exactly. So let's go to the BigQuery. Let's go to the BigQuery UI really quickly here. So BigQuery UI, and then I can probably make it my whole screen for a little bit. Again, everything's over here, or I'm too lazy. I'm going to do BigQuery. Boom, even better. And it brings you to it has all my saved random things, and it brings you.
By the way, Patrick, you're not kicked off stage. You might have to go, but we're still going another 10 hours on this channel.
Yeah, yeah, I know you guys are beast moding it. Yeah, I actually have a hard stop at 10.
It's all good.
Or at in 15 minutes, which
I want the link to the where you got that chair, by the way. It's a cool chair.
Oh my goodness. I mean, just Google gaming chair. Like
dude, I've been Googling gaming chairs for weeks.
Oh cool. Yeah. Gaming chair.
No, sorry, I didn't mean to slow you down. Keep going.
I'm with I know you're good.
Yeah, I was looking at the Titan. Anyway, keep going.
You're good. Password, Google chair. We got it all. We're learning everything about you, John. This is great. But yeah, so we're in Google's BigQuery right now, and the reason why this is so fantastic, especially with Chainlink, is like I was saying, Chainlink is this data pipeline that brings data on chain that allows our smart contracts to basically unlock and go to the next level. So Google BigQuery has a ton of public data sets of it's a data buffet. Kind of whatever you want. You can come in here. There's probably a database that does it. And then if it doesn't, You can, you can add databases, explore public data sets. There's more than just kind of what's in this sample stuff here. For example, this blockchain ETL was one that, we added here. So we are going to actually be looking through this, through some Aave ones. If you hit details over here, it'll actually give you a query to run. And this one returned no results. So maybe let's do something else. I'm kind of picking random ones here. A token event balance transfer. I don't know what this means, but let's see what it does. Oh, this is probably Aave's A tokens whenever they get swapped around. Yeah, so this is exactly what it is. So it gives you all this data. So it scrapes the Ethereum chain for you, and then we can even, we just grab this this transaction hash of this this A token transfer, and we can go to Etherscan and we can even verify here. Let's say, okay, let's grab that hash. And we can see exactly what this person did. We have no idea who this person is. We just know that they're the most recent A token transfer. And we can see what they did. They withdrew 686 synthetics from Aave. They supplied 135 Chainlink token to Aave, and then they executed a swap with their A SNX and their A link on one exchange. So we can see everything that they did, and it's all in this Google BigQuery. So it makes it really, really easy to query the Ethereum chain. And then, like Devin was saying, because they have their full archive node that is recording all this. But what's also interesting is a lot of smart contracts, you're going to want more than just Ethereum data. Maybe you want maybe you have like an insurance contract and you want, the incidents in an area where somebody's living. Great. You can pull that in,
Let me stop you right there real quick. I mean, this is an interesting point. So in fact, as you know, with baselining, the only three smart contracts are the org registry, the validator, and the shield contract, right? That's all that goes on chain. Everything else is business logic off in your SAP system or in your database, what have you. And so what's an interesting question is, how can we take what we're doing here inside of a smart contract, and within the baseline framework, say, okay, I also need to have effectively deterministic data for the fact that I'm running, maybe 5 counterparties machines. I mean, just local machines that all have to calculate the same value.
So sorry, could you repeat the question there?
Yeah. So say, for example, I've got a purchase order.
Yeah.
And you and I and a regulator, an auditor, and 2 other counterparties are all party to this work step, right? This purchase order that's going, and that purchase order is based on a rate table, because it has to calculate the correct rate for a discount, right? This is our canonical case in baselining. But say I also wanted to, if it's 3 o'clock, I'll give you rate 1, but if it's 3:01, I'll give you, or 3.0001, just to make the point, I'll give you a different rate, right? So I've got 5 different counterparties or whatever I said, calculating that function. Not a chain. It's not a smart contract. It's not on the blockchain. It's just function. And those 5 counterparties, number 1 is going to calculate it, just over the line at 3.0002, and we're all going to get different results, and the proof that goes on the blockchain will fail. So this is where I think about Chainlink a lot, right? And Oracle, we need, wherever there's a variable going into a function, whether it's on chain or off, we need to make sure that everybody's getting the same data, especially in highly dynamic data.
Yeah, that's honestly, that's spot on, and yeah, that's a perfect use case, right? Creating this definitive truth for, okay, when was this put in? Is it 3? Is it 301? Excuse me. So you can calculate the correct rate. It's really important. I mean, it's the difference between potentially a massive amount of money, depending on the protocol, of course. So
yeah, they're not here, but we'll definitely get. There's some folks on the maintainer team that you guys should get to know, like Kyle Thomas and Karthik Solaprama and others. I have to think, and Anais, this is something we ought to talk about in the standards team. Is where would you, and in the construction of a zero knowledge circuit, right, using Socrates or Planck or what have you, where would this be? Like, would we construct a zero knowledge circuit to enforce correctness on a particular work step, where the zero knowledge circuit is predicated on a Oracle lookup? Does that make sense to you, Patrick?
Yeah, I think that makes a lot of sense to me.
The question is, that's the limit of my knowledge. I'm not sure it can be done. I've never thought about how you would integrate a chain link call inside a zero knowledge circuit.
I think that might be a longer conversation.
Oh, it's much longer. Yeah, absolutely.
This
is the kind of stuff that we want to throw the fish hooks out for folks later after you had to leave.
Yeah, for sure. So maybe I'll just have to come back later on today, do an impromptu. Let's talk about oracles and chain link. Yeah, that sounds like that would be a lot of fun.
Yep, Anais, we can't hear you. Sorry about that.
Oh, is she muted? Was she gonna?
She was off mute, but maybe the mic is off or something.
All right.
But yeah, we'll come back.
Well, yeah, I'll keep going. I'll just try to rip through at least this part for the duration of the demo here. But so we can run any query that we want, and this is great because we can get this really powerful data from Google's BigQuery on chain, powering our smart contracts, triggering our smart contracts. And again, in a production system, we'd obviously want to do this in a decentralized fashion with multiple chain link nodes, with multiple sources. But having this source right here is really, really powerful. So I have.
Sorry, if I could add one thing, Patrick. For those who want to learn more about this data set, it's a great open source project on GitHub, blockchain-ETL. You can just Google that, and you can find all the maintainers and the team that's behind this, who's really built and continues to maintain these data sets. Yeah,
definitely check it out. It's really cool. I mean, I had kind of just a ton of fun, just like, look at this data set, look at this, just literally a buffet of fun of data here. So, but yeah, just in the last couple minutes that we have here, how do you actually get this into your smart contract? How do you get this data to power your smart contracts to do something really cool? And again, you build what's called an external adapter. So an external adapter is basically an API for Chainlink that Chainlink can understand and Chainlink can digest. And this is an example of the BigQuery's API. I have it listed on market.link. This is a service that lists nodes, and it lists services with Chainlink nodes. It has all the documentation here. Definitely check it out if you're interested in adding it to your node or working with the node. All the README, all the docs are in here. I'm just going to kind of breeze through it because we have only 5 minutes left. You're going to want to yarn it to install the packages. Yarn starts. It creates a simple server, and then we can run a simple curl on it, and we should get back this result here. So I know I'm kind of going quick because we only have 5 minutes here, but this was a curl I ran that pinged this server that I'm running. And oh yeah, even in the server side, it says what the result is. And so the query I did was I was just selecting some information from the Ethereum lending protocol showing the flash loan history. And I just got the block timestamp. So what was the most recent block timestamp of the most recent flash loan? That's the most recent block timestamp there. Or excuse me, sorry, block number. This is the block number of the most recent flash loan. Why would you want this data? that's kind of up to you, but really any data that you want, you can get. And yeah, so that's just kind of quick how the server works. Now, how we actually connect to the node, and I'm probably going to skip over a little bit of this. We can actually upload this as a cloud function, create function, give it a function name, give it a region, give it a variable. The variable that I have is in the documentation. I'm just going to kind of skip through this because I've already uploaded it. I'm just going to hit, where's the next button? It's behind my mic. And then you'll just do like a zip upload of the file that we zipped. So I didn't show myself zipping it. So you just do zip. I forget what the actual command is. Hold on. Sorry, my terminal's a little messy. Okay, I don't have the zip here. Oh, wait, is that the zip? Zip clear. Okay. The zip's in here somewhere. You zip it up, and then you just upload it to the Google Cloud like this. So I'm not going to do that because I already did it. BigQuery Chainlink external adapter. We can even test it to make sure it's working. Data. I think this should work because I have defaults. Yep, it should work. So it's defaulting to that query that I just gave. This Google Cloud function is actually querying Google's BigQuery, giving a result here. So then the last piece to do is we're going to grab this trigger actually, and we're going to go back to our Chainlink node, which I have up, right? Yep. Localhost. I'm going to sign back in, and we're going to open to this bridges section. So this bridges section is where we add our external adapters. We're going to create a new bridge. I'm going to call it BigQuery Chainlink external adapter. Add the bridge in here, and now we have this bridge. And now when we create a job, I don't have time to create a job here, but when we create a job, we're going to add an adapter. So in your jobs, you'll have like what's called like your tasks list. In this tasks list, we can do BigQuery Chainlink external adapter, and this will actually pull the data from BigQuery from our cloud function. You can check out the Chainlink docs. I'm sorry we didn't have enough time to go into it and actually show you the demo here, but that's what it would look like. And we did see a successful testing of using this cloud function, reading from the Google's BigQuery. And then, yeah, then that's the last step. You just add it to the job spec, and now you have a way for your smart contracts to get data from BigQuery. So I know we covered a lot, and I know we actually didn't even get to cover everything that we wanted to cover, but I feel like this definitely proves like how powerful the entire GCP suite is for hosting these Chainlink services, for getting data into your smart contracts. We talked about, creating definitive truth, creating, these really empowered smart contracts. And I got a couple minutes left here if we have questions.
Hey, Ani, so are you back on online there?
Yes. Can you
There
hear
you
me?
are. Yeah.
Okay.
Hey.
So thank you, Patrick. That was great. I was trying to address a point that was made earlier, so I will go back quickly to this. And basically, in the baseline context, what we need to investigate together is there a best approach, a generic method that will allow counterparties involved in baselining to align on a given data point. And this will vary depending on use cases, right? In the ones that John mentioned, we were looking for alignment and sign off on time. But in other use case, we may have to agree on the exchange rate. If an option asset is priced in euro, for example, and we want to tokenize and basically make it available to investor on-chain in different currencies, we need to agree on when are we capturing the exchange rate and what should be the fixed exchange rate, blah, 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 things like that. So, and there are, I think, many ways that can be done, and we can explore within the current baseline protocol framework. Should it be done at circuit level, which is what John was mentioning, or should we have another smart contract or even the existing shield contract handling some kind of Oracle operations that will allow or that will leverage basically the Chainlink functionalities. So those are the type of ideas that I think from a specification point of view, we should really not think about use case specific and domain specific, but approach it from an infrastructure point of view to identify the best method, or compare and contrast. It might be that at the end of the conversation, you realize that there is no best approach and it has to be use case specific. And maybe we don't want to go custom circuit, and there is no way to do a generic circuit to do that. But those are definitely having Kyle and having all the rest of the team involved in that conversation would be very, very valuable.
Yeah, that'll be interesting, and hopefully Devin can be part of that as well. I know Patrick's going to have to jump, but and Patrick, if there are other Chainlink engineer folks that you want to send into this session throughout the rest of the day, please encourage them to do so. It'll be live, and the reason why we live stream is so that people can kind of scrub back to the action and catch up. And it's could you show us, well, maybe it's your last trick, what is the attribute in Chainlink that allows me to set the specific time or instance of a particular piece of data, that especially dynamic data, because what we could do in a generalized way maybe is I'm having one of those hunches, which are, it's nice working on the margin of ignorance, because it's my job. But it strikes me that you could have a generic, it's not a primitive, but it's sort of a generic abstract action where a circuit isn't really doing anything with the link data, but is saying, in order to pass, you have to have gotten this particular time frame or attribute.
Yeah. So
yes.
Fantastic questions, and those are spot on. In that, those are exactly some of the problems that Chainlink solves. So, so this right here is a visualization of the Chainlink price feeds, and basically what the question really is what's the current price of Ethereum in USD? And so the best way to kind of come to this conclusion in a decentralized fashion is you add a ton of independent operators. So these are all independent node operators, and they all respond with different answers, and it gets aggregated on chain. So now we have this decentralized definitive truth. Now it's the same thing with timing. When is, in that example we used earlier, did this person submit it before or after 3? You have a decentralized network, almost kind of like a network of peers. And again, it's the same concept that makes blockchain work today. Respond, say, hey, they returned this at 2:59, they're good. Or maybe one or two of them say, they returned at 3, no good, give them the higher rate. But this is a functionality that's actually native to the core Chainlink protocol. It's called the sleep adapter, where you can say, hey, can you execute this at this time, or can you execute this in 20 minutes? And those are exactly some of the things that Chainlink adheres to. Now, if you really want to do it with a single node, you can.
I think that's the point. You wouldn't want to, right? I mean, look at all these different values, right?
Exactly.
You want to get the definitive value, and so you'd want to pull that. Can you show in the code, like if I was writing, I know you're probably not writing a lot of ZK circuits, but say I was writing the logic for that particular function.
Mm-hmm.
Right. Where am I going to get the call from? Just if you can bring people back to that, like where would I go to get that endpoint? I did a lot of work in the API economy, so I always think of endpoints and verbs.
That's spot on. So if you're so you're talking about for an off-chain service, right?
Well, regardless, right? I mean, whether it's in the zero knowledge circuits, they all run off-chain.
Mm-hmm. Yeah. So
they deposit on chain. But.
Yeah. So this is an example of getting the latest price using those prices that I just showed. This is where all the code is. What you would do, and this is doing it in Solidity. This is getting it in like JavaScript or Python.
Perfect.
Doing it in JavaScript or Python. What you're going to do is you're going to get the ABI of the contract that you're working with, the address of that contract, which again, that contract is aggregating all the results from these, in this case, these decentralized, I'm going to call them like alarm clock oracles, because that's kind of essentially what they're doing. And those oracles say, hey, you know, it came in at this time. And yeah, you can literally just do exactly that. You can make an API call to the blockchain, connect to the Ethereum chain, and then grab that definitive truth value on chain, and then power the rest of your services. So
yeah, this really opens it up for me. This right here. I mean, like I'm going to timestamp this particular spot because this is where, the imagination kind of opens up and say, yeah, this is where we can work with this.
Yep. So I do have to jump off right now. I'm sorry that I got to go. It sounds like we could have a lot more fantastic discussion, but thank you so much for inviting me. I hope you guys learned a lot, and it sounds like there's a lot of fantastic stuff for us to build moving forward. Thanks, Patrick, and thank everybody over at Johan and Adeline and everybody that made this happen. Appreciate it. And yeah, let people know. Engineers, Chainlink Army engineers, come on in. We're here all day. Absolutely. All right, guys. Thank you so much. All right. Bye-bye. Thanks, Patrick. Oh, or Marines. Thanks, or Patrick. Whatever they're, whatever the Chainlink guys are. Marines, Army, lots of very enthusiastic people. Devin, what did you think of that?
That was great, John. And unfortunately, I also have to run. I have dinner ready on my end here, but yeah, excellent.
Yep, I hear the kids.
Oh yeah, but yeah, excellent conversation. Yeah, I'm definitely excited to. I mean, it's great to see this demo of Chainlink accessing public data, and yeah, looking forward to the next sessions here in the Baseline Summit. Yeah, I think what we'll do is we'll make sure that people know about this at the 10 a.m. plenary. And then we'll just time warp it. We'll have people go back in time, and yeah, if you're available, or if I know some other folks from Google have been in and out a lot over the last day. And I think Anais and I are going to be particularly interested in where this goes from a standards perspective. So maybe we can take that offline.
Yes, definitely.
Excellent.
Thanks, Devin.
Thanks, everybody.
Cheers.
Yeah, take care.
Thank you.